It's fair to say that the Amiga and the Archimedes systems suffered completely different fates over time. Where the Amiga processor was abandoned, the Acorn systems found themselves in the doldrums for a long time, where ARM processors were only used for mobile devices. But later, with things like the BeagleBone, they came back into vogue for desktop systems. The consequence now is that there are very, very fast 32-bit ARM processors available. I mean, this is a Raspberry Pi that's running at 2400 megahertz, and it's natively running 32-bit ARM code, which is all RISC-OS needs. Because there are fast processors available for the old Acorn operating systems, and this is version 5, which is a modernized version, but still very true to the original, quite CPU intensive apps work reasonably well. So, for example, you can look at manuals actually on the computer itself. You'd be quite hard pressed to do that on an Amiga. If you wanted to look at a PDF, it's not a great experience. So this is opening a PDF on RISC-OS 5 on an Acorn successor, essentially. See, we can move the window around smoothly. Now, where these systems fall quite flat is they have the amazing CPU, but they have very basic graphics still. They don't have any of the acceleration or special custom circuitry of an Amiga. So sound synthesis is in software, and really the graphics are software as well. Here we've got like a block diagram of certainly the original Archimedes computer, and it has the ARM processor front and center, the memory controller, which does provide virtual memory functions, so each application in the desktop is running in its own memory space. But as you can see, there's not any custom sprite hardware or custom sound hardware in the computer at all, and that obviously still isn't. This operating system is very low level. It's written in assembly language, and it runs on the ARM 32-bit processors. So we're at peak processor support at the moment. Modern ARM processors have dropped 32-bit support. So this A72, and it can only use one CPU, but this A72 in the Pi 400 is possibly close to as fast as this is ever going to get. Maybe there'll be a few more 32-bit processors the platform can move to, but I think this is near the end. This is peak RISC-OS hardware support, I think. It has a multitasking operating system, but unlike the Amiga, it's a cooperative system, so any badly behaved or even vaguely badly behaved program can hang the entire session. It does have a task window function here, which is actually providing what is normally the single tasking basic with a window to run in within the multitasking Windows environment. So in terms of graphics, you've got all of these, I think what Amiga people would call chunky modes, which obviously do support large numbers of colors, because there's a tremendous amount of memory available in these Raspberry Pis, and the system can see 2 gigabit, I think. I don't have a tremendous number of games on here. There is the equivalent of WHD load, but I don't think it works on this particular Raspberry Pi 400, so we're kind of stuck here with the more of the editors, development tools and productivity software that was built in. The system did come with a nice kind of object drawing package, you know, a bit like Illustrator, but about 1000% simpler. And it also comes with a built-in paint package. Another good example of raw speed of the ARM processor, certainly compared to the older versions which used to run at 8 megahertz, is this illustration. So this would have taken ages. You could have watched it drawing this before, and it's instantaneous on a 2.5 gigahertz processor. The set of benchmarks coming up compare this processor with the original, still reasonably fast, strong ARM based 230 megahertz RISC PC processors, or maybe the 200 megahertz versions, still pretty quick. But you know, we can see here that obviously a modern ARM processor like the A72 in the Pi is thousands, literally thousands of times faster. See the results here. You know, you've got percentages there, 3,358% quicker at processor instructions and so on. So it's like a massive increase in speed, although the graphics are not as accelerated. Again, they don't have any custom hardware to speed them up. This is just a little utility that allows you to kind of zoom in and look at the user interface a little bit, get some detail. It's kind of a little toy really that they included. A lot of these little apps are actually written in BASIC as well, which is quite interesting. Obviously the BASIC now runs at the same sort of speed as machine code used to. I should probably try and get some games, but there really aren't any good ones on here. Just these little utilities to play with at the moment. I think we have something like a version of Minesweeper if I can find it. I mean, it just strikes me as a shame that the Amiga didn't benefit from, you know, Moore's law and the acceleration of advanced processor capabilities well until they were reinvented by the Vampire team. If Motorola hadn't abandoned the 68K, it would have been running at, I think, 2 gigahertz now. I have no idea why they said it couldn't be modernized. I think that was the craziest thing I've ever heard.
Aw, shame. Next!
I think it would be fun to kind of explore the differences and similarities between these two computer systems, and certainly the history of them and how it diverged and what that meant for the communities behind them. A lot of similar stories here as well. If you're interested, then please like and subscribe.